So I've got a question here for us to look at. As I'm looking at this, just reading through it, a few things stand out to me. Right? First, it's talking about distances, it's talking about times, and it's talking about rates or speeds. Right? Anytime I see those three things together in a question, I immediately think, okay, great, I've got a formula that relates those three items. Right? Distance equals rate times time. So that's the way I'm going to arrange the information here. And I like to put these things in a table, right? On the one hand, I have the two trips in the first column, and their rates, their times, and their distances. I always try to set these things up so that we can multiply across the columns, and rate times time is going to give us distance. Okay, so I have two rows because we have two trips, one on the flat ground and one in the mountains. So with that filled in, I'm going to go to the question, and I'm just going to start reading it, right, from beginning to end, pulling out numbers, putting them in my table. So the question says, a semi-truck travels through 300 miles on the flat ground. Okay, so let's put 300 in for the flat ground distance. And in the same amount of time, it travels 180 miles through the mountains. Okay, so the mountain distance is 180, and the times are both the same. Now, I don't know what they are, right? So I need a variable, but I'm going to put the same variable in both rows in that column, right? Because it's the same amount. Okay, now the next sentence here, the rate of the truck is 20 miles per hour slower in the mountains than on the flat ground. Okay, I need another variable here, right? I'm going to use R for the rate of the truck on flat ground. And in the mountains, it's 20 miles per hour and less than that. So the mountain rate will be R minus 20. Okay, excellent. Filled in my table. Now let's multiply across the rows, and we'll get some equations. First row gives me R times T equals 30. And the second row gives me R minus 20 times T equals 180. Okay, good. Two equations, two variables. Now they're nonlinear equations, which is a little concerning, but we should be able to deal with this. All right, so let me get some space here. Right, this is the same question again, but with our two equations. So what I'm going to do is I'm going to solve both of these equations for t. All right, so I'm going to take the first one, divide both sides by r, and it becomes t equals 300 divided by r. And I'm going to take the second one, divide both sides by r minus 20. So t is equal to 180 divided by r minus 20. Okay, well, if t is equal to both of those two things, then I can set those two things equal to each other. Right? It's a substitution, essentially. So that gives me this equation, 300 over r equals 180 over r minus 20, and this I can solve. Right, this thing I can solve. I'm going to start by cross-multiplying, and I'm a little out of room, so I'm going to jump up to the next column here. That gives me 300 times r minus 20 equals 180 minus r, and now it's just going through the steps. We'll distribute 300 into the parentheses. 300r minus 6,000 equals 180r. Rearrange some things. Subtract 180 from 180r from both sides, and I'm going to move the 6,000 over to the right side. So this becomes 120r equals 6,000. And finally divide by 120. R is equal to 50. And that's what I was looking for. We weren't asked for the time, right? I mean, we could get the time. The time is, if you look way back over that second equation on the left, the time is 300 divided by r, so that's 6. It's a 6-hour trip. But we need the two rates. So let's jump back to the table. And I've got my final answer here. R is the flat ground rate. So the speed on flat ground is 50 miles per hour. And the speed in the mountains is 20 less than that. So the speed in the mountains has to be 30 miles per hour. And there's our results. So if you like this, please don't forget to click on the like button down at the bottom here. And if you'd like to see more, there's also a button down there where you can subscribe.